Good day. Today we are going to look into plotting a hyperbolic function. Plotting a hyperbolic function. Now, what is a hyperbolic function? A hyperbolic function is a function that is in the form of f at x is equal to a over x minus p all plus q. So if you see a function in this form, then you must know that that is a hyperbolic function. For example, if you see a function like this one, for example, y is equal to 1 over x minus 2, say plus 3, then this kind of a function is a hyperbolic function. How you going to see that this is a hyperbolic function? You are going to see with this x as a denominator on the bottom, then you will know that this is a hyperbolic function. So you will have something like this as well. Y is equal to 1 over x. The question is this hyperbolic function? Yes, this is a hyperbolic function. And then the thing is, in this hyperbolic function, our q is 0 and then our p is also 0. So the biggest indicator of a hyperbolic function is the x that is on the denominator part of whatever that is on the right hand side. That is how you see that this is a hyperbolic function, because it is very important for you to be able to identify a hyperbolic function, so that when you know how to solve it, you will know when to use those kind of solutions. Because it does not help to know solutions but you do not know where to use them. So we are going to talk about hyperbolic functions and how to plot them. And then an equation of a hyperbolic function is called an hyperbola. So when I say hyperbola, or they're saying hyperbolic function, it's one and the same thing. It's just that it's different naming for different reasons, something that we'll talk about later. So before the session, we want to be able to say at the end of the session, what is it that you want to achieve? So number one, the objective, number one, we want you to be able to plot the graph. Now, which graph? The hyperbolic graph or the hyperbolic function. And then you need to know the components of the hyperbolic functions. Each and every function has their own components, and then they have their names. So you should know what those names are so that you can be able to work with them. And then the third objective will be to find f at x when given what? A graph. Find f at x when given a graph. So if they give you a graph and then they say find the hyperbolic function or hyperbola, how do you do that? Right? Okay. Now, when we are plotting, so what I'm going to do is I'm going to outline the steps of plotting a hyperbolic function, and then we are going to pick an example and be able to use that example in order to explain things, so that we'll see how things goes. All right. So what are we doing? We are plotting a hyperbolic function, right? Now, when we are plotting a hyperbolic function, so what is going to happen? How are we going to get by solving hyperbolic function? So step number one, you must choose the quadrant. You must choose the quadrant, and then we'll talk deeply about that. And then number two, you must find and plot asymptotes. We'll talk about asymptotes later. And then number three, you must find y-intercept. Int stands for intercept, and then you do that by let x be equal to 0. And then number four, you find the x-intercept by letting y to be equal to 0. And then lastly, you need to plot and label. All right. So let us pick a function and try to do it following this step, so that we can see if these steps work or not. All right, I'm going to pick a very fundamental function. I'm going to put the steps here. right? And then we can be able to deal with it. So let's pick a fundamental hyperbolic function, and let's discuss it and see how far we can go. Okay, let's say you've got y, which is equal to, say, a over x. All right. So now, what am I doing now? I am dealing with the first step. How do we choose a quadrant? So if you've got a is equal to, if you have y is equal to a over x, if a is positive, greater than 0 simply means positive, therefore your graph are going to be on your first and third quadrant. Quad for quadrant. So if your a is greater than 0, which is positive, then your graph is going to be in the first and the third quadrant. And then if your a is less than 0, which means positive, therefore your graph will be on the second and fourth quadrant. That is how you choose the quadrant. Let's take an example. Let's say you've got y is equal to 1 over x. All right, you've got y which is equal to 1 over x. Now, ladies and gentlemen, so here is your graph. This is y and this is x, and then there is 0 here. So the value that is here is 1 and it is positive, so it's greater than 0. That means your graph will be where? It will be on the first quadrant. This is the first quadrant, this is the second quadrant, this is the third quadrant, this is a fourth quadrant. All right, so because this value is a positive value, which means it's greater than 0, therefore your graph is going to be where? Here, I'm going to put the dots here, and where? And here. So it's going to be here and here. Let me demonstrate that one using a fundamental graph. There we go. And then there we go. Right? So that is basically how you plot a simple and a fundamental hyperbolic function, which is 1 over x. But let's say now we've got a different situation. Let's say now we've got y. Let me use a different color so that you can see this. Let's say now you've got y, which is equal to minus 1 over x. Now, can you see here what is the difference? What is happening here? Here, the value of a, which is here, is what? Is minus 1. Minus 1 is negative. So that means your graph will be on the second and the fourth quadrant. So it's going to be something like this. Okay, and then you've got y here, you've got x here, and then your graph is going to be second. Where is second? Here, just this one and this one. Okay, so positive first and third quadrant, negative second and fourth quadrant. That is how you do the first step. All right, that is how you do the first step. All right, now other steps are relatively easier, and some of them you have encountered them in other instances, so it will be very, very, very easy to deal with them. All right, so I was just trying to explain. Okay, so Let us take a function and let's call this function y is equal to 6 over x plus 1 and then plus 3. All right, and then we are trying to plot. So they say you must plot y is equal to 6 over x plus 1 all plus 3. Okay, so how do you go about plotting this kind of a graph? Step number 1, choose the quadrant. Now you must find the value of a here. Remember that the general equation for this is what? Is y is equal to a over x minus p plus q. So step number 1, choose the quadrant. Okay, now before we can get to choose the quadrant, let's just put our graph paper here, a graph where we're gonna put, let's use this one, let's put it here so that it looks nice, and then we plot it here. Let's say this is our y-intercept, and then let's say also this is our, and then this is 0. Okay, so step number 1, choose what? The quadrant. Okay, our a is equal to 6, which is positive. So what does that mean? That means our graph is in the first and third quadrant. All right, okay, so whatever our graph will be, it's going to be here and where, and then here. All right, so we are done with the first step. Now second step, find and plot asymptotes. So there are two things there. Number 1, you must find the asymptotes, and then number 2, you must plot those asymptotes. So let's start with finding the asymptotes. Now there are 2 kinds of asymptotes, ladies and gentlemen. We are finding and plotting asymptotes. That is step number 2. Okay, there are 2 kinds of asymptotes. The first asymptote is called there is a horizontal asymptote and then there is what? There is vertical asymptote. Now what is an asymptote? Let's start there before we deal with horizontal and vertical. An asymptote is a line. That's a very important thing. It's a line, but what kind of a line? It's very important. Both of these things are lines. Okay, but it's a line that exhibits certain properties. Now what are those properties? It's a line that the curve will approach but never touch. All right, so the curve will approach but what? But never touch. What are those? Those are asymptotes. So when you are talking about a horizontal asymptote, is an asymptote that is standing like this. It's a line that is like this. The graph or the curve will approach those lines. Approach means getting closer and closer, but they will never touch. A vertical one, it will stand like this one. Okay, vertical, and then horizontal is like this. Okay, horizontal is like this, and then vertical is like this one. All right, now how do you find a horizontal asymptote here, and how do you find a vertical asymptote? Now guys, a horizontal asymptote goes like this. Okay, so if it goes like this, guys, then it will cut what? It will cut the y-axis. So the horizontal asymptote will be what? We'll start with x. I'm talking nonsense. It won't start with x. The horizontal asymptotes, guys, will go like this along the direction of the x-axis. Okay, so if it goes in the direction of the x-axis, it will cut what? It will cut y. So when we describe it, it's going to be y. We're going to describe it according to what it cuts. Let me actually write this thing down so that you can actually have it. We will describe it according to what it touches. Okay, so, or cut. What does it touch? It touches the y-axis, so it's going to be y is equal to something. So we're going to take the value that is here literally as it is and put it as a horizontal asymptote. So in this particular case it's 3. So horizontal asymptote here is y is equal to 3. Okay, do you understand? So you go to your graph. Now you've got your horizontal asymptote and it's y is equal to 3. So you go to your graph and then you look for y is equal to 3. So let's say y is equal to 3 is somewhere here. So let's say 3 is somewhere here. So what you're going to do is you are going to put this y here, and then but you must put dotted lines. Okay, and then you must label that this is y is equal to 3. This is your horizontal asymptote. So you found it and then you've plotted it. Now what about the vertical asymptote? Now when you want the vertical asymptote, guys, you must literally take what is here and then you must equate it to 0 and then solve for x, and then you will get the vertical asymptote. Now let us try that and see if it works. All right, so let me put this here. Okay, it's here. So here we've got x plus 1, which is equal to what? We take it, we get to 0, and then we solve for x. When we solve for x, we're gonna get x is equal to minus 1. So x is equal to minus 1 is what? Is our asymptote. And remember earlier what we said. We said we name asymptotes in terms of where it does what? Of where it's cut. So here is our graph. We've got our vertical asymptote, which is x is equal to minus 1. So what do? We then say here is minus 1, and then we put dotted line, guys. Dotted lines, please. It mustn't be. Okay, so we've got minus 1 here, somewhere here. Here there was 3 here. And then please, ladies and gentlemen, personalities, you must also label your vertical asymptote. That your vertical asymptote is what? Is y, sorry, it's x is equal to minus 1. So which step was that? It was step number step number 2. So you have found the vertical and horizontal asymptotes, and then now you were able to plot them. Okay, so now what is going to happen now? So next step, you must find the y-intercept by letting x to be equal to 0. Now let's quickly do that. We're going to take all of this off so that we can use the space, because we don't need the space. Okay, so for y int, what do? We let x to be equal to 0. So in this case, we've got y, which is equal to 6 over 0 plus 1 plus 3, which is same as what? Which is same as 6 over 1 plus 3, which is equal to 6 over 1 is what? Is 6, and then plus 3 is 9. So you've got a point here. Now what is this point? This point is y, which is 9, and then what about x? X is equal to 0. Right? Now that is how you found the y-intercept. Now when you have found the y-intercept, what do? You must go and put it somewhere. Okay, so x is equal to 0, so x is equal to 0 here. I wrote nonsense here. X is equal to 0, and then y is equal to 9. Guys, you must be very careful. Right, let's continue. So x is 0, and then y is 9. Let's say 9 is somewhere here. Remember, guys, this is not down to scale, so let's put this 9 here. Okay, so here's a point. Okay, so we've got a point here, and then now we are going to do what? We are going to go to the next step. What is the next step? The next step is to find the x-intercept. Okay, let's find the x-intercept. So x-intercept, how do you find it? You let y be equal to 0. So 0 is equal to 6 over what? Over x plus 1. Okay, plus 3. So what happens? You take this 3 to this side, and then you get 3 is equal to 6 over x plus 1, and then you need to cross multiply here. When you cross multiply, you end up with what? You end up with 3x plus 3, and then because this is, you multiply this and this, and then you multiply this and this, and then you get 6. Okay, take this to this side, you get 3x is equal to 6 minus 3, right? And then you get 3x is equal to 6 minus 3 is what? Is 3, and then you divide by 3 here, you divide by 3, and then you get x, which is equal to what? Which is equal to 1. So the x-intercept here, y is what? Y is 0, and then what about x? X is 1. That is our, we are making a mistake. We are making a mistake here. Remember, when this 3 went to this side, it's supposed to be negative. Okay, so if this is negative, so if we multiply this and this, you're gonna get minus 3x, and then we'll end up with minus 3 here, and then because of that we'll end up having 6 plus 3. Okay, and then so this whole thing changes, and then we will get 3x, which is equal to 9, and then divide by 3 and divided by 3, and then 3 over 3. What are we going to get? Gonna get x here, and then you still have minus, yes, minus, so we're gonna have minus 3 and then minus 3, and then we're gonna get x is equal to minus 3. So our x is equal to minus 3. So we have an x-intercept here. Our x-intercept is what? X is minus 3. And what about our y? Our y is 0. So we've got the x-intercept and the y-intercept. Alright? Let's just, I can see you guys, you may be confused by this. So let's just actually start it afresh so that we can be able to put it in a very good context and then explain everything well. Okay, we're looking for x-intercept, and then we let y to be equal to 0. So we ended up with what? With 0, which is equal to what? Which is equal to 6 over x, what? Plus 1 plus 3. Okay, so and then we take this 3 to the side, and then we got minus 3, which is equal to 6 over x plus 1, and then we divide it by 1 here so that we can cross multiply. Now when we divide by 1 we get minus 3. Let's actually do this, and then we get it with x plus 1, and then which is equal to 6 times 1, going to get 6, and then this multiplied by this is going to be minus 3x, and then this multiplied by this is going to be minus 3, which is equal to 6. Okay, and then when you take this 3 to this side, you're going to get minus 3x is equal to, remember this 3 is positive, so when you take it to the side it's going to be what? It's going to, so it's negative here, so if you take it to the side it's going to be positive, so it's going to be end up being something like this, 6 plus 3, and then you get minus 3x is equal to 9, and then when you divide by 3, and then you divide by 3 here, you end up with something like this. You end up with minus 3, cancel this, we'll cancel this one, and then x is going to be 9 divided by minus 3, you're going to get minus 3. So that is how you get this value. And then so you go back to your graph, and then you will have another point, which is, this was minus 1, I think minus 2 is somewhere here, and then minus 3 is here, minus 3. This is going to be your x-intercept. So x-intercept is going to be here, and then your y-intercept is going to be here. And then, so what is the last step? The last step is to plot and label. So when you plot and label, we do this and then this in appropriate quadrants. Which quadrants do we have now? We have quadrant 1 and quadrant what? And quadrant 3. Guys, when we get asymptotes, both vertical and horizontal asymptotes, then our asymptotes changes the orientation of our graph. So now our graph is still going to be the same graph, but now it's going to go from here and it's going to cut where it's supposed to cut. Okay, and then this line will continue like this. It will approach this line but never touch. Remember, it is an asymptote. And then another part of it, it will go from here and then pass here and then pass here. All right, now this is our graph. Now what is our graph? It is y, which is equal to 6 over x plus 1, and then plus 3. This is our graph. Guys, excuse my drawing. My drawing is terrible, but please do write something that is far better than this one. All right. Yes. Okay, guys, now let us do our last part of the work. Guys, let's say we're not given the formula of a graph, but we were asked to do what? We were given a graph like this. Let's just do what we are famous for. We're given a graph, and then we're not given a formula, and then we're supposed to find the formula. So how were we going to do that? Remember, this is x, which is equal to minus 3, and then y is 0, and then here x is 0, and then y is 9. Okay, these are intercepts. Okay, so let's say you were given this, and now they say you must find the graph. So how to do that? Guys, this is very easy. So what you simply do is you realize that this is a hyperbolic function. So if it is a hyperbolic function, whatever function that we're going to get is going to be in this form, in a form of y is equal to a over x plus a minus p plus q. It will be something like this. Okay, so what do we do? Step number 1, find the asymptotes. So which asymptotes are we going to get? We're going to get the asymptote let's look at the asymptotes that is here. This asymptote is y is equal to 3. So this y is equal to 3, you take it directly as it is, and then you put it where? Here. So now we are cancelling this one now. What do we put here? We put 3. Okay, and then so we are done with this asymptote, the horizontal asymptote. Now let's take the vertical asymptote. What is a vertical asymptote? A vertical asymptote is, here it is, it's x is equal to minus 1. So it's x is equal to minus 1. So what would we do? So we look at this asymptote and we say, okay, before this asymptote came here, what was it? We know it was x plus 1 is equal to 0. Okay, so this, if you solve it, it becomes this. So because it was taken from here, then we take this as it is, and then we replace this with it. So we replace everything, and then we say x plus 1. All right, so that is the second step. Okay, you can write those steps yourself. Now, what are we left with now so that we can finish? We're left with the a. So how do we find a? Guys, to find a, what we simply do is we pick any point. It doesn't matter which point, any point, but that point must be on the graph. Okay, we can pick that point. If we pick that point, then we can use it and we can find what we're looking for. Okay, let's pick this point. X is 0 and then y is 9. So pick 0 versus 9 as a point. And then what you do is, in a place of y, what you put? You put 9. And then you put this a is equal to, in a place of x, you put what? 0. Okay, 0 plus 1. And then plus 3. 0 plus 1 is 1. A divided by 1 is a. So you end up with 9 is equal to a plus 3. And then you take this 3 to this side. It's going to be 9 minus 3 is equal to a. And then 9 minus 3, 6 is equal to a. So what does this mean? This means a is equal to 6. So when you have done with this, you then just remove this part and you put what? You put 6. So here is your graph. It is y is equal to 6 over x plus 1 all plus 3, which is exactly this one, ladies and gentlemen. All right, so you can be able to do this. It's very easy, guys. You use this point, but you can also use this point or any other point as long as that point is in the graph. So ladies and gentlemen, before we wrap up our today's session, let's look at what our objectives were and see if we're able to meet them. So the first objective was to plot the graph. We did speak about how to plot the graph. And then the second objective was to know the components of the function. We spoke about the component, we spoke about the asymptotes, we spoke about Xintercept, we spoke about Y-intercept and all of those kinds of things. And then we looked, and then the third objective was whether can you be able to find f at x if you are given a graph. And then we were able to look at the graph and we were able to find f at x. So that means our objective of today was done. And then lastly, as we are closing shop, now guys, this function is like this. Okay, this will never be 0, but this one can be 0 and then this one can be 0 as well. Because for example, if you have y which is equal to 1 over x, basically this is 1 over x plus 0 or minus 0, doesn't matter, minus 0 plus 0. That means our p, our q is what? Is 0 and our p is 0. All right, and another thing that is important, guys, so p and q can be 0, but what? But a can never be 0. Otherwise, that will not be the hyperbolic function. Okay, so and then another thing that is important, which is very important, and b, sometimes there is no x or y intercept. Okay, sometimes there is no x and y. So if you calculate x and the y intercept and you get 0, it's okay sometimes, or you don't get anything, it's okay. Sometimes we do get such situations. Ladies and gentlemen, these were hyperbolic functions, and enjoy. And if you have any questions or something that you don't understand, please do not hesitate to do what? To ask me on the comment section below, and then I will be able to answer you as soon as I can. Ladies and gentlemen, thank you very much for listening to Hyperbolic Function. This is Mqondisi Macaba from Thembela Maths Club, a club that assists learners with mathematics. Have a lovely day and goodbye.